In previous videos in this series, I've demonstrated how to use Hype to make animated drawings and handwriting graphics for whiteboard explainer videos. My approach showed how to coordinate drawing and handwriting with the image of the presenter's hand. These videos also included ways of making natural connections between drawing parts with invisible curved lines and many other effects to mimic handcrafted graphics. In this video, I'll take these animated drawing techniques one step further by demonstrating how to make vector graphics with a more realistic hand-drawn appearance, and I'll do this using an external drawing program rather than Hype's native tools. Many apps can export vector graphics, but there is no easy way to animate these external SVGs once they're imported into Hype. Here, I'll show you one way to overcome this problem using CSS and the Hype timeline. Importantly, we'll be able to do this without having to write any JavaScript or CSS code directly. In the examples I'll show, there is some code running in the background, but it works its magic automatically. So, this is an ideal solution for non-coders. Lastly, I'll show you how to add a complementary handwritten font, and animate it using a typewriter effect. We'll also achieve this effect without having to write any new code. If that sounds interesting to you, let's get started by showing you an animated drawing of the workflow needed to implement this hand drawing style. In this video, I'll go systematically through each of the steps from vector drawing to video recording. I'll start by helping you choose from the many external drawing tools out there. We'll do this by considering which of these tools best fits our purpose and which are the easiest to learn and use. Hopefully, this will also clarify why they can be more useful than Hype's native vector drawing tools. Next, I'll explain how to configure the output from these external programs to generate vector paths in a form compatible with animation and Hype. From there, we'll import these graphics into Hype as independent parts and paste them into a series of empty elements. This is necessary to properly sequence each component in the overall scene animation. In fact, we'll do this by adding some parameters to each container that specify their relative order and the duration of each component's animation. We'll do this using HTML attributes entered via Hype's Identity Inspector panel. Next, we'll use the timeline to sequence parts of the overall animation. We'll go through a similar process for the text animation, and then we'll be ready to launch the entire scene animation and record our whiteboard video. For many people, the vector drawing program of choice is Adobe Illustrator. And you can absolutely reproduce line drawings with this hand-drawn style in Illustrator. However, many of the ways you might do this in Illustrator are incompatible with the CSS animation technique we're using here. For instance, using elaborate strokes of different widths or those made with custom graphic brushes doesn't translate well into simple line drawings. There are just too many extra paths or anchor points introduced for them to be drawn efficiently. In fact, despite the popularity and power of Illustrator, there are some other tools that are better suited for our purpose. For example, there are tools like Excalidraw whose sole purpose is to sketch diagrams in this hand-drawn style. Or, if you haven't brought into the Adobe CC ecosystem, you might want to use the free alternative, Inkscape. In a similar fashion, there are free tools like Draw.io whose main function is making diagrams. In deciding between Illustrator and these alternatives, there are a few things you should consider. Firstly, is there a hand-drawn output mode, or will you have to do the line roughening manually? Secondly, is the output composed of simple paths rather than some combination that includes paths and shapes? For the purposes of conversion to a roughened style, shapes are not particularly helpful. Behind the scenes, many programs decompose these shapes into a series of arcs rather than a single path. This can ruin any subsequent attempts to animate the drawing of that shape. These paths should be as simple as possible. That means having the minimal number of anchor points with consistent stroke width and being drawn in a predictable direction. When pencil tool drawings are made, there should be a way to smooth the output to reduce the absolute number of anchor points. Another thing to consider is whether your drawing program allows partial exports. This is important if you want to sequence how your drawing is eventually animated. And finally, how efficient is the tool in producing drawings or diagrams that make good whiteboard graphics? These Illustrator alternatives all have hand-drawn output modes. In fact, there are multiple possibilities in each case. Unfortunately, these possibilities aren't universally helpful. Many add extra paths or break shapes into a series of unrelated segments. For each option, I've listed the settings that work best to produce paths compatible with the CSS line animation technique we'll use later. It's important to note that sometimes these tools produce acceptable outputs for lines but not for shapes or pencil drawings. In general, Inkscape and Draw.io generate the best results most often. As a rule of thumb, you should aim to produce the simplest output path possible using hand-drawn shapes rather than shape primitives offered by the drawing tool. Ideally, you will also want some control over the way your drawing is exported. Because line animations are typically drawn in a serial fashion, you'll likely want to export each part of a larger diagram in its desired drawing order. For this reason, it is handy to have a tool that supports partial exports. This is true for Excalidraw and Draw.io, but unfortunately, Inkscape is somewhat limited in how it exports drawing parts. And finally, when comparing the relative drawing and diagramming efficiency among these free Illustrator alternatives, there is one clear winner, and that is Draw.io. Given all these considerations, I would recommend using Draw.io with the sketch, comic setting. Draw.io is free, and it's available as either a desktop app or a web app. Whichever drawing tool you prefer, it is essential to remember that the following CSS line animation technique is only compatible with SVGs containing simple paths. This means that SVGs containing gradients, varying stroke widths, or color fills probably won't work as expected. Implementing this CSS line animation technique requires that the SVG be embedded as an inline SVG. This means that importing the SVG file into Hype is more complicated than simply adding it via the resource pane like a regular image file. In fact, there are 3 additional steps. The first step is to open the SVG file in a code editor. You can use any code editor you like. My preference is VS Code, but literally any code editor will do. Next, you need to copy the SVG code from the editor to the clipboard. And finally, you need to paste the SVG code from the clipboard into the inner HTML of an empty Hype element. You can make an empty Hype element by placing a shape, say a rectangle, onto the scene canvas. There are several ways to access the inner HTML of this element. With the shape selected, you can either use the keyboard shortcut Command Option E or by going to the Edit menu and selecting the Edit Element's inner HTML option. Once you do this, a blank text box should appear. Paste the SVG code from the clipboard into this text box. Now the SVG is inserted as an inline element inside your Hype project, and you should be able to see it on the scene canvas. At this point, you'll probably want to make the underlying shape invisible by removing any border or background fill. In our animation workflow so far, we've inserted an external SVG into an element on the Hype canvas. Our next task is to add a class and attributes to that element so that the code running in the background recognizes it as something to animate and exactly how that should unfold. The first step in that process is to select an element designated for animation and add a shape class to it. This is done using the Identity Inspector panel, like this. Once this connection is made, we can pass further information to the JavaScript functions running in the background using HTML attributes associated with this element. You can see a place to enter these attributes, a little further down in that same inspector pane. It's essential that you name those attributes correctly, otherwise, they won't be recognized by the background code. I've zoomed in on those here so you can see exactly how they are configured. As you can see, each attribute is composed of a key-value pair. There is one key-value pair for drawing order, one for the duration in seconds, and one to block drawing altogether, just in case you want to stop its animation for some reason without having to delete it completely. The name of each attribute key must start with the word data and be followed by a dash. I've included a link to this sample project in the description below. This will allow you to examine this code and the settings that accompany it in more detail and potentially customize it for your own purposes. The next step in our workflow is to add actions to the Hype timeline that specify when we want each line animation to begin. These timeline actions will call a JavaScript function called drawNextShape. That function is already nested inside our code example, so you don't need to worry about creating it. This function loops over all the elements in the scene with the shape class and determines which is next in line to be drawn based on the drawOrder attribute. It then looks at the other attributes associated with that element to determine the animation duration in seconds. Then it automatically executes the line animation. To use this function, all you have to do is to place a run JavaScript action calling that function on the timeline at the point you want each animation step to begin. If you aren't familiar with adding timeline actions, this image shows that process. You'll need to repeat this step for each separate SVG segment you want to draw. You should space out these drawing events according to their duration, otherwise, your line animations will potentially overlap. Now, if you run the project in a browser, you'll see the line animations in action. However, if you were to just run the timeline on its own, you won't see line animations. The JavaScript functions involved need to be run in a browser to execute properly. So that's how we set up and sequence our line animations. Now, let's move on and prepare the scene to use animated handwritten labels. Not surprisingly, it's a very similar process. But before we start, I'd like to mention the handwritten font I prefer to use for this style of whiteboard video graphics. It's called Virgil, and it's an open source font initially made especially for Excalidraw. You can download this font directly from virgil.excalidraw.com. The font is already installed in our sample project, but I'll also put a link to it in the description below. Of course, you can use any font you choose, but I like this one as it's designed to match the rough and line appearance I've been cultivating here. So just like before, we need to add empty elements to the scene at the locations we want to insert animated labels. These containers should really be empty. I know that seems strange, but don't worry, we'll add the text programmatically later. However, you do need to set the properties on this container. In this case, that means selecting the font and font size you want to use. We set these properties in the typography inspector. This typing effect works best if you also set the text alignment property to left justified. It doesn't matter that we're doing this on an empty container. In fact, if it helps you, you can put some placeholder text in this container while you set up the scene. Just remember to delete it, along with any border or background fill, before you play the animation. Next, we need to add a class to specify that this is a label designated for animated typing. As before, this is done in the Identity Inspector pane. And then, we need to specify some HTML attributes just like we did for the line animations. In this case, the attributes are called shouldType, type order, type speed, and text to type. This last attribute is where you enter the label text you want to be typed. The last step in our development workflow is to add a set of functions that type these labels to the timeline. Predictably, this function is called typeNextLabel. It works in a very similar way to the drawNextShape function we used earlier. Each time this function is reached on the timeline, it loops over all the elements in the scene with the label class and then animates the next one in line based on the type order parameter. Consequently, we need to add this function just once for each label, and the process for doing this is almost exactly the same as before. The only difference is that we select the typeNextLabel function for our run JavaScript timeline action, as shown here. Once we do that and play the animation in a browser, we get the combined effect of line drawing and label typing operating together. Now, all that is left to do is record the entire scene as a video. You do that by selecting the File, Export Movie, Video menu option. And that's it. I hope you enjoyed this quick introduction on how to leverage external SVGs to make hand-drawn whiteboard graphics in Hype. I've put the sample project code demonstrating this approach on the Hype forums, and it is linked below. If you are interested to learn more about the neat things you can do with Hype, please check out my YouTube channel for other related videos. If you are interested to learn more about other things we are working on, please check out our website at alteredmindware.com or contact me directly at alteredmindware@gmail.com.